Hi everyone, and welcome to the first lecture of the tree series. Over the course of this series, I'll be covering all the problems from the CSES tree algorithm section, starting with the first one in this lecture. Let's begin with the first problem, which is subordinates. Now, given the structure of a company, your task is to calculate for each employee the number of the subordinates. Right? This is the given sample tree. There are 5 nodes, and for the second node, the parent is 1. The third node, the parent is 1. The fourth node, the parent is 2. For the fifth node, the parent is 3. Right? This is the tree basically. Now, subordinates are the number of nodes that are the descendants of a particular node without including that node itself. Right? For 2, they are 1 subordinates. For 3, they are 1 subordinates. For 4 and 5, it would be 0. And for the first node, there are 4 subordinates. And let's look at a bigger tree. Now, for 10, there are no subordinates. For 11, there are no subordinates. For 9, we have 2. For 8, we have none. For 6, there are 4 subordinates. For 7, there are 0. For 3, it would be 6. For 2, it would be 2. For 4 and 5, it would be 0. And for the first node, we have 10 subordinates. And what we can notice is, for a particular node, the number of subordinates is the subtree size of that node minus 1, since we are not including that node itself. Right? So the answer for a particular node X would be the subtree size of that node X minus 1. Now we need to find an efficient way to calculate the subtree sizes of all the nodes in the tree. Now let's say we have a node U and 2 has children V1, V2 and so on. Let's say till Vn, and we need to find the subtree size for the node U. And let's say we have the subtree sizes for all of its children. So we know the subtree size for V1, V2 and all of these nodes till Vn. Now the subtree size for the node U would be the sum of the subtree sizes of all of its children plus 1, right? Because we are also including the node U. Thus the sum will increment by 1, right? And the subtree size for the leaf nodes would be 1, right? And using this, we can solve the problem. Now let's see how. Now we can call the DFS upon the first node. This will call the DFS on all the children of the first node, right? And firstly, the first node will call the DFS upon the second node. We'll calculate the subtree size for the second node and return the answer to the first node. Now the first node will call the DFS upon the third node, calculate the subtree size and return. Then we'll sum them up, add 1 to it, and then return the answer for the first node. Now let's look at the code. Firstly, this is the input part. We are taking the parent for each child, and for the parents we are pushing the children, right? Now this is the DFS part. Firstly, we are setting the subtree size for each node as 1 to include that particular node itself. Now for all the child of that particular node, we are firstly running a DFS on that child and then incrementing the subtree size of that node by the subtree size of that child. Right? And for the leaf node, it would be 1 because there are no children. Now printing the solution, which is decrementing the subtree size by 1. This is the whole code. Firstly, we have an array of vectors for the children, then an array for the subtree size. Right? And this is the DFS part, the input part. Firstly, we are calling the DFS on the first node and then printing. So that's it. Make sure you subscribe and share. Thanks for watching.